Yes, good morning, everyone. And I'll be starting today's class with a bit of introduction of what we had done previously. That is, how we are going to mathematically write the Fourier series equations and Fourier coefficients, and what do you mean by the average value of it. As you all know, that we had already started with the introduction aspects of Fourier series. Okay, I had told you to remember the table, the continuous time signal when it is periodic and aperiodic, that is periodic and a non-periodic signal. And later on we had discussed a few bit of discrete time when it is called as a periodic function and it is a non-periodic function, and so on. Okay, so now let us start today's class with a simple numerical problem which will be discussed by me. Okay, so I'll be carefully solving this example problem which is there in the exercise. Okay, so I'll be teaching you the concepts quite clearly. All right, so and later on it's your responsibility to obtain such like Fourier coefficients, what we will be discussing in the coming minutes, and how to form the harmonics content, and how we are going to write the exponential Fourier series expansion. All right, so now let me share my screen now. Okay, yes, so this is the problem that is there in case of the Fourier series expansion that is written in the exponential representation there. Okay, the problem goes this way: obtain the exponential Fourier series representation for the waveform x of t shown in the figure below. Okay, I repeat, obtain the exponential Fourier series representation for the waveform x of t as shown in the figure below. Okay, so this is the representation of the Fourier series, that is the continuous time signal. Okay, so I want you to tell whether it is a periodic signal or aperiodic signal. Can anyone tell me what is the periodic signal? Once you call this as a periodic signal, what is the period of it? Okay, so once you call it as a non-periodic signal, and it would be having no such period there. Okay, so can anyone tell me by unmuting themselves? Okay, so whether it is a periodic signal or a aperiodic signal?
Periodic signal.
Yes, exactly. So it is said to be a periodic signal where the fundamental time period. Okay, so x-axis represents the time here. So you have to determine the exponential Fourier series representation. Just before that, you need to find out the total time period there. So I'll tell you quite clearly. Okay, those who have missed or those who have forgotten how we were able to do the periodic and all. So this is where if you just start it. Okay, so this is -2 to -1, that is 0, and from -1 to 1 it is said to be unity. Okay, I think I have not written the magnitude. It is said to be unit magnitude there, and from 1 to 2 it is said to be 0, right? So it is said to be repetitive in nature with the smallest possible constant. Okay, so this constant is generally called as the time period there. Okay, so omega naught, which is said to be 2 pi divided by t. Okay, so omega naught is what we need there in our exponential Fourier series representation, that is 2 pi divided by 4. Okay, so that is said to be pi by 2. Okay, so omega naught is said to be 0.5 times pi. All right, so this is how I find omega naught. Okay, so omega naught is said to be 2 pi divided by t, so that is 2 pi divided by 4, that would be equal to pi by 2, or 0.5 into pi. Okay, so now what we'll be discussing here in getting this solution of this problem is, we know that x of t is said to be periodic, right? So with capital T. So how we are going to define it analytically? How we are going to define it analytically? Okay, so what I mean by analytic representation is, so we have a period that is said to be equal to 4. I have from -2 to -1, and again from -1 to 0, and 0 to 1, it's having a unit magnitude. So and from 1 to 2, again it is said to be 0 there. So now I have two magnitudes which I need to write. Okay, so how do I write it? So once when I start from -2 to -1, okay, so when t would be less than or equal to -2, less than or equal to -1 here. Okay, so what is it? What is the magnitude there? That is said to be 0. That is said to be 0. Okay, so now at -1 to 1, okay, so at -1 to 1, I have the magnitude that is said to be, which will be unity there, right? Okay, so at -1 to 1, so -1 to 1. So if you see this area over here on the x-axis, so -1 to 1, I have a magnitude which is set to be equal to 1 here, and at the other one, which is at t is equal to 2. I mean, sorry, 1 to 2, right? So t less than or equal to 2 and 1. So it is said to be equal to 0. So analytically, if I want to write this periodic waveform, I can write it as the expression what I've written there as for x of t. Analytically, x of t, which is said to be periodic, is represented like this. So x of t is said to be 0, 1 and 0. So you need to write the magnitude. This represents the magnitude scale. Okay, so this represents the magnitude and this represents the time domain there. Okay, on the x-axis what is represented. So this is the time scale axis what I have written there on the right hand side, and on this side it is generally the magnitude which is representing. Okay, so why I am telling you this again is, if they tell you to write it analytically, okay, so if in the given waveform, once you say it is said to be periodic, you need to write it in an analytical manner. So this is the periodic signal. So it is said to be a continuous time Fourier series representation for a periodic signal. Okay, so this is how you are going to guess, or you have to not guess, generally you have to remember in such a way that, so you need to go for a periodic signal. So how its representation is done for a continuous time periodic signal, CTPS, okay, periodic signal, what it represents. So this periodic signal will have a Fourier series representation. So not the Fourier transform. Okay, so one thing you have to remember, you have to go for the Fourier series representation. Okay, so in the coming classes we'll be discussing about Fourier transforms also. You should not get confused. All right, so that is the reason why I'm telling this again and again. Okay, so now I have represented it in an analytical manner. Okay, so x of k. Okay, so what is x of k? So that is where you are going to find out the Fourier coefficients. Okay, so Fourier coefficients will be found out with representation called as x of k. So x of k is nothing but the Fourier coefficients. Okay, so these are nothing but the constants which are being present there. So these are also called as complex Fourier coefficients. Okay, complex Fourier coefficients. Complex Fourier coefficients, x of k. So that is x of k. How it is to be defined? So it is being defined as 1 divided by t integral. Okay, so this is said to be periodic in nature. X of t e power minus j omega naught k into t dt. Okay, so x of k, that is represented, or that is defined as 1 divided by t integral. This is the time period which is there. This is x of t, the continuous time signal, and this is the exponential representation. Okay, so this is how we are going to write the complex coefficient, that is complex Fourier coefficients. Okay, so now giving the representation. Okay, so I have capital T, that would be equal to 4. Okay, so omega naught, what is omega naught? The value of it, it is
0.5 pi.
Yeah, 0.5 into pi, that is right. Okay, so now I have omega naught is equal to pi by 2 or 0.5 into pi. Okay, so now this one is said to be x of t, and this is where it is said over one complete period. Okay, so I repeat, it is one complete period. One complete period. Okay, so let me go for the substitution. 1 by 4 integral. So it would be from minus 2 to, okay, so from minus 2 to plus 2 there, right? So but I can generally think in such a way that, so minus 2 to minus 1 it is 0, and again from 1 to 2 it is 0. I can simply write it from minus 1 to plus 1. Okay, so that is there. And what is the value of x of t? That is said to be equal to 1, and e power minus j omega naught, that is said to be 0.5 pi, okay, into k into t, okay, dt. Can I write it like this? Okay, So that's how I can write this representation. So 1 by t, okay, t is said to be 4 here. This is t. And why did I write from -1 to +1? Okay, so its value, which is said to be over a complete time period. Okay, so this integral, whatever that represents, okay, this integral, it is over one complete time period. Over, okay, over one complete time period. Over one complete time period. Okay, so this is where it is representing, and this integral, what it is there, so it is over one complete time period. So why did I write as -1 to +1? So both the amplitudes were said to be equal to 0 there. So the amplitude which had a positive value was, or a non-zero value, I can generally say it as from -1 to +1, its value is said to be equal to unity. Okay, so this is where x of k is to be determined. Okay, so I'll use this equation. I'll tell you how did I box this equation, or how did I consider this equation once I need to find the value of the complex Fourier coefficient. Okay, so this is the equation what is to be represented, and I'll come back to this equation shortly. So now I have x of k that is represented as 1 by 4 integral -1 to +1. Okay, so 1 into, okay, e power minus j 0.5 pi, okay, into k into t dt. Okay, so that is there. So now e power at, integral e power at. So this entire thing forms a, okay, whatever that is, I'm writing here. Okay, so 1 by 4 integral, so integral e power at dt. Okay, so that would be e power at divided by a. Okay, so limits a to b, if there are limits a to b, and the limits has to be used appropriately. So I'll use this equation, that is the value of the integral equation that is there. Okay, so e power minus j 0.5 pi into k. Okay, so so that is how you are going to write it. So e power minus j 0.5 pi into k into t divided by minus j into 0.5 into pi into k. So that is there from -1 to +1. Okay, so that's what I'll be writing here again. So can you quickly evaluate this integral? Okay, so I have this one. Okay, so can you quickly evaluate this integral? It's the value of t that you need to substitute. Just remember that. Yes, to the value of t, if you are there in the meeting. So can you evaluate the integral? That is e power minus j into 0.5, okay, into pi into k into 1. Okay, so that is again minus e power minus j 0.5 pi k into -1, that divided by minus j into 0.5 into pi into k. So I can write it as, okay, so 1 divided by 4, which is there. Okay, I can write it as e power j 0.5 into 1, so minus into minus, that would be plus, that is e power j pi by 2 into k. Okay, so that is there, e power j into pi by 2 into k minus e power minus j k into pi by 2 divided by, okay, so divided by, so what it is there. So how you are going to write this? Can anyone tell me? Yes, can anyone unmute themselves and they can tell me what should be in the denominator? Yes, you can unmute yourself and you can tell me, not a problem. Okay, let me write it here. Yes, so this 1 by 4, okay, so I'll write it again. So here I have minus j into 0.5 into pi into k. So I can write it as 0.5 or I can just write it as minus j into pi by 2 into k, right? So now what I can do here is I can split this 1 by 4 as 1 by 2 into 1 by 2, right? So that is e power j k into pi by 2 minus e power minus j k into pi by 2 divided by, okay, so divided by the equation minus j, okay, minus j into k into pi by 2, so multiplied by 2 again, right? So this forms another equation where you can write it as 1 by 2 e power j k into pi by 2 minus e power minus j k into pi by 2 divided by, so this equation what is representing here, so it forms a 2j into k into pi by 2. Hope you agree to this, right? Do you agree to this? I have taken the minus sign common. That's the reason why I can write like this. Okay, so if you are getting what I have written here, so I have taken the minus sign outside, so which are not shown in the previous steps. I have taken it directly and I have written it here. Okay, so moving on to the next one, I can write this as 1 by 2 into sine, okay, sine k into pi by 2 divided by k into pi by 2. Do you agree to this? So I have written it in terms of the trigonometric function as sinusoidal. Okay, so sinusoidal is the trigonometric function that I've used here, and I have written it in terms of the trigonometric function. So that e power jk into pi by 2 minus e power minus jk into pi by 2 divided by 2j. Okay, so I'll write it as sine k pi by 2, that would be equal to e power j k into pi by 2 minus e power minus jk into pi by 2 divided by 2j into k into pi by 2, right? So this is how I can represent it. All right, so if I want to write this one, I mean sorry, yeah, so this is how I can write it. Okay, so 2j, that is there, so I'll be using the same equation over here, there, right? So 1 divided by 2 k into pi by 2 is taken as the common factor, and I have written it like this. Any doubts up to this point, I'll be able to answer it, and you can unmute and you can do let me know if you have any doubts. Okay, so
Once again.
yeah, sure. Okay, so see here, I have skipped the steps here just for your notice. Okay, so look here, this one. Did you understand how did I write this? X of k, the complex Fourier coefficients.
Yes,
Can
sir.
it be? Yes, thank you. So this is written here. I'll come back to this again. Fine. So now this is the Fourier coefficients what I need to write here. That is x of k, that would be equal to 1 divided by 4 integral minus 1 to 1. So why did I write only as minus 1 to 1 is, if you have seen this is the minus 1 to 1. Okay, so all the other magnitudes are set to be 0. So integral under the time period, that is capital T, so that needs to be evaluated. Yes, so you have only one such value where it is from minus 1 to 1 as a positive value. Okay, so now this integral equation, that is e power at dt, so how it is evaluated? E power at divided by a, with the limits being from b to a. So right, so this entire thing is taken as a, that is minus j into pi by 2, okay, into k. This entire term is taken as a. Okay, so e power at. So along with the k, okay, if you are not seeing it, let me erase this and write it again. K into t. So this k here represents the small letter a here, right? So this small letter a, which is to be written e power at dt. So this needs to be evaluated. So I have written it like this. Okay, so now if I substitute the limits here, okay, so I can write this like 1 by 2 into 1 by 2. So carefully evaluate the limits here. So the limits has to be done for t. Okay, so there is no other t term here. So denominator does not have any other t term. So small t will be present there in the numerator itself. That's the reason why I am writing it like here. Okay, so moving on to the next steps, you have the equation for exponential representation of a trigonometric function. So keeping that in mind, I can write it as the exponential function as 1 divided by 2 into 1 divided by 2. So this term will be just added here, like it will be like division, I mean taking a part of it, 1 by 4 and 1 by 4, I can write it as 1 by 2 into 1 by 2. Okay, so this part of the 1 by 2 gets used in the equation here. So 1 by 2 into e power jk into pi by 2 minus e power minus jk into pi by 2 divided by 2j into k into pi by 2. Okay, so that is what you can write it here. Okay, so this term what I represented in terms of the brackets, okay, so that forms the sinusoidal function there. Okay, this sinusoidal function, we know that. Okay, so we know that sine k into pi by 2, that would be equal to e power jk into pi by 2 minus e power minus jk into pi by 2 divided by 2j. Okay, so that is what I can write here. So this k into pi by 2, which was there in the constant, that will be retained. I hope I have answered your doubt.
Yes, sir.
Okay then. Okay, so once you get this right, so this is how you can write the Fourier coefficients. But so I already know that what is the definition of x of 0. Can anyone tell me? What is x of 0? It is called as the average value. Okay, so average value or the DC value which is there. Okay, so in order to find out x of 0, if you use this equation, okay, so you will be getting an indeterminate, right? So you can give the value of k. This value here represents the k value, small k value which is there. So if you give k value, it would be an indeterminate, right? Okay, so 0 divided by like 0, that would be an indeterminate, isn't it? So now in order to find out the average value, that is x of 0, okay, so go back to the equation what I have written here. Okay, so use this equation to find out the average value. So because why I am taking, so keeping that in mind, I am taking the average value from the waveform. So how did I write that waveform? Using this x of k, that is I have represented the Fourier coefficients over this equation, the definition of it. So it is saying that it is for one complete time period. Okay, so in order to evaluate this one complete time period, so I'll be taking the average value for one complete time period. So to find x of 0, the average value or DC value. Okay, so I'll be evaluating this. Okay, so keep this in mind. So once you have set it, so x of k, that would be equal to 1 divided by 4 integral minus 1 to 1 e power minus j into pi by 2 into k t dt. Okay, so this is where you have to evaluate it. So give the value of k as 0. Okay, so that is where you have to find out, that is x of 0, that would be equal to 1 divided by 4. So that is e power 0, that is 1 integral 1 dt. Okay, so hope you are getting what I'm doing here. So that is x of 0, that would be equal to 1 divided by 4. Okay, so integral along with the limits I have left out here, that is 1 and 1, this is t. Okay, so 1 with this is minus 1 here, sorry. So 1 minus of minus 1, that is 2. Okay, 1 by 4 into 2. Okay, what is its average value? That is to be equal to 1 by 2. Okay, so the average value, to find out the average value, I'm taking it over one complete time period in order to evaluate the average value. Okay, so the DC value, how we are going to evaluate, not from the final equation what we get, so but from the Fourier coefficients what we have set up. I mean, what the mathematical way that I'm going to express it, that way I'm going to write it here. Okay, so x of k, that would be equal, defined as 1 divided by 4, that is integral from -1 to 1. So this k value which will be equal to 0 and it is said to be equal to 1. Okay, so integral 1 dt. Okay, so it would be t, and 1 with minus of -1, that would be equal to 2. Okay, so 1 divided by 4 into 2, that would be equal to 1 by 2. Okay, so this is how you can find out the average value. To find average value or DC value. Okay, so from now on it is quite simple. Okay, we have got x of 0, that should be equal to 1 by 2. Okay, I'll write it here, x of 0 1 by 2, that is the average value of it. Average value. Okay, average value or DC value. Fine. So now what I'm going to do here is, so we know that we need to express in terms of the exponential Fourier series, right? So the representation has to be done in case of the exponential Fourier series, that is x of t, for the function x of t that is given there. Okay, so I'll write it here, exponential way of representing the Fourier series, the Fourier, F-O-U-R-I-E-R, Fourier series of given x of t, exponential way of representing the Fourier series for the given x of t. Okay, so can you recall what we had written for x of t? That would be from sigma, k would be from -infinity to +infinity, k would be from -infinity to +infinity, that is x of k e power j. Okay, so plus j k omega naught into t. Okay, so sigma, that would be written as k equals -infinity to +infinity. So what you are going to do here is, I have written for x of 0, that would be 1 by 2. So what you are going to do here is, you are going to have few values that you need to write. Okay, the value of k, okay, and x of k. So make a tabular column in such a way that you keep on giving the values, simple values. Okay, so that what you are going to represent, and see how it has been changing. So we have k would be equal to 0, x of 0 would be equal to 1 by 2. All right, so now what I'm going to do here, I'll be giving it for 1, 2, 3, 4. Okay, I'll be giving 5 such values like this. Okay, so along with 0, it is taken as a DC value. So this is 1. Okay, so if I give 1, I'll be having 2 such values, that is positive and negative values. Okay, so and again, okay, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5. Okay, so what you are going to do here is, you are going to find out the values of x of k. Okay, so x of plus of minus 1, what is the value? Okay, so you are going to find it for plus 1 as well as minus 1. Okay, so check whether both the things are equal. So you are going to check for plus or minus 2. Okay, so use x of k. Okay, so for plus or minus 1, plus or minus 2, use this value. Okay, so how we are going to write? So that is 1 by 2 into sine k pi by 2. Okay, 1 by 2 sine, okay, k pi by 2, okay, divided by k pi by 2. All right, so 1 by 2, okay, into sine pi by 2, sine k pi by 2 divided by k pi by 2. So that is x of 1. Okay, so 1 by 2, okay, sine pi by 2, which is 1, divided by pi by 2. Okay, so what's the value of x of 1? Can anyone tell me quickly here? Yeah, so 1 by 2 sine pi by 2 is 1. Okay, divided by pi by 2. Okay, so 1 divided by, what's the value? So that is, yes, can anyone tell me what's the value quickly? 1 by 2, that is, can be written as 0.5 divided by pi by 2. Okay, so 0.5 that is divided by pi by 2, that would be written as 1 divided by pi. Okay, so again, what you can write? So x of 1, that should be equal to 1 by pi. Okay, so now similarly, what is x of minus 1? What is x of minus 1? Okay, so x of minus 1, that would be 0.5. I have written 1 by 2 as 0.5 sine, okay, minus pi by 2 divided by minus pi by 2. Okay, so 0.5 sine pi by 2, that would be equal to -1. Okay, so that is -1 here. That should be equal to minus 0.5 into pi. Okay, so I can write it with the negative sign being cancelled, 0.5 being cancelled. That should be equal. Okay, so give the values of plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5. So I have got the values here as plus or minus 2, that is 0. You have to verify these values here, minus 1 by 3 pi for plus or minus 3. And for plus or minus 4, that is 0. For plus or minus 5, that is 1 divided by 5 pi. Okay, check these values. Okay, check these values, what I'm going to write here. This is where you are going to represent it. Okay, so now, okay, so this is how you are going to write it for x of k, and I'll give it to the things. Okay, so how you are going to write it for exponential Fourier series representation, you can write it and you can represent the values quite clearly. All right, so this is how we are going to write it for the exponential series function. Okay, so this is where you are going to write the exponential series, that is x of t, that would be equal to sigma k equals minus infinity to plus infinity. Okay, x of k e power, okay, e power j k omega naught t. Okay, so this is where you are going to write it. So just show it for 5 values on the left hand side, that is less than 0, and 5 values on the right hand side, and 1 DC value there. So hope you can do this. And x of t, the representation, I'll give it to Rohini. Okay, so she'll be sharing how to write this x of t over the summation being written here. So x of k values, the complex Fourier coefficients is known to you, and x of t is how you are going to represent it. So based on the solution what she will give, I'll be giving you the highlights about the harmonics. Okay, so with this note, I would be like ending the session.